Dismantling of machines. At the end of this topic, you will be able to record necessary data from the main plate, identify front and back shields, dismantle machines, introduction to dismantling of machines. Electrical machines play an important role in all types of industries. Preventive maintenance and field repairs of an electrical machine are important to avoid heavy production losses. So, it is necessary to overhaul the electrical machine to ensure the sufficient working and performance of the machine after their own running hours are completed. During the overhaul and repairing process, it is necessary to dismantle the machines. Let us discuss in detail. Recording data from the main plate. The first phase of dismantling process is recording the machine details from the name plate. The electrical machine name plate outlines the power, speed, voltage, and current rating of the machine. Here, we have taken a direct current motor for dismantling. Let us record the machine details from the nameplate one by one. In the nameplate, the first row, first column, represents the frame type. Here, the frame type is open drip proof. The first row, second column, represents the British standard of the motor. BS 5000 Part 99 represents the rotating electrical machines for particular applications or miscellaneous applications. The first row, third column, represents the duty cycle of the motor. Duty S1 represents the continuous duty. That is, motor works at a constant load for enough time to reach temperature equilibrium. The first row, fourth column, represents the insulation class. The electrical machine insulation is classified by the temperature ranges at which it can operate for a sustained period of time. Here, the insulation class is F for the total temperature range of 170 degrees Celsius. The kilowatt power of the machine is 1.5 kilowatts. The speed of the machine is 1,500 RPM. The voltage of the machine is 220 volts. The current rating of the machine is 15 amps. The ambient temperature of the machine is 170 degrees Celsius. In case of DC machine, additional information will be present to represent the excitation rating, which is not usually found in AC machines. Here, the excitation voltage of the machine is 220 volts, and the exciter current rating is 0.95 amps. Next comes the bearing specification for the commutator end and the non-commutator end. In the commutator end, the bearing specification is given as 6306 ZC3. Here, the first number represents the bearing type. 6 means the Conrad type bearing. The second number represents the dimension series, and 3 stands for medium series machine. The next two numbers represent the bore diameter, and here 06 is the bore diameter of the bearing. The fourth alphabet denotes the type of bearing shield used. Here, Z stands for single shield in the bearings. The letter C3 represents the radial clearance of the bearing, and C3 means that it is looser than normal. The type of winding in the machine is shunt winding. In the last row of the nameplate, IP and IC rating of the machine are given. IP rating gives ingress protection of the machine, against the dust particles and fluid. In the IP rating, the first number represents the protection against dust particles, and 2 stands for protection against the solid objects over 12 millimeters. The second number represents the protection against the fluid, and 1 stands for protection against the vertically falling drops of water. The IC represents the index of cooling of the motor, and 01 represents the open drip-proof machine. The last specification represents the machine number for the manufacturer reference. By this way, we can extract the data from the machine nameplate. Identification of front and back shields. Before dismantling the machine, it is necessary to identify the front and back ends of the machine. According to the NEMA standard, the end of a normal motor, which carries the coupling of the driving pulley, is called as back end or drive end or D end. The end of a normal motor, which is opposite to the coupling or driving pulley, is called front end of the motor. This is sometimes called as opposite pulley end, or commutator end, or non-drive end, or N end. After the identification of front and back ends of the motor, let us start dismantling the machine. Dismantling of electrical machines. The tools required for the dismantling of machines are different sizes of spanners, Allen key set, screwdriver, hammer, mallet, and extractor. Using the screwdriver, loosen the screws of the terminal box. Open the terminal box cover and identify the terminals of the machine. Unscrew the nuts and bolts of the ventilation cover using the suitable size spanner and remove the ventilation cover. Identify the brush holder in the motor assembly. Loosen the leads which go to the stator from the brush holder. Remove the brushes from the brush holder. Unscrew the nuts and bolts of the front end cover of the machine using the spanners. Remove the front end cover of the machine with the help of the screwdriver and hammer. Similarly, unscrew the nuts and bolts of the back end cover and remove the back end cover of the motor using the hammer. After that, the rotor of the motor will come out easily. Remove the bearing gasket from the rotor using the screwdriver. Fix the extractor in the bearing and screw the shaft of the rotor to the extractor to remove the bearings. Unscrew the extractor to remove the bearings from the rotor. The stator of the machine carrying the field winding consists of 2-pole wave winding in the field connection. The dismantled parts of the machine are displayed here, which include nuts and bolts, rotor, yoke with field winding, front end cover, and back end cover with brush holder. Hope you have understood the dismantling of machines. Summary. In this topic, you have learned about recording the data from the main plate of the machine, identification of the front and back shields of the machine, dismantling of machines,